Hi and welcome. So what I'm going to try this time is I'm going to experiment with heat treating some 4140 steel. If you'd watched one of my other videos, I had some really serious difficulty getting a good surface finish on this 4140 chrome moly when I was turning it on the lathe, and it was suggested to me by a longtime machinist that if you partially harden it, the finish will be much better. So what I'm going to do is I am going to not heat treat this part. One of these parts I am going to just heat treat and not temper, which will make it full hardness, which is up to Rockwell 49. The next one I'm going to heat temper at about 800 degrees Fahrenheit, which should make it about 39 Rockwell hardness. And the last piece will be about 13 hardness, which is its annealed state, which is how I get it. So next step is going to be to put these in stainless steel wraps so that I don't get a oxidation layer on top of it when you do the heat treat part of it, because you're heating it to 1550 degrees Fahrenheit. And then I will start my kiln and run the ramp procedure to get the temperature right. So this next step, I put the stainless steel wrap around it and crimped it all the way around, and now I am going to add some wires in the top fold so that it'll make it easier to remove. Give me something to grab onto. So, matter of fact, that might be a good idea. This is annealed, soft annealed wire, not zinc coated, because if it was galvanized, the zinc melts at something like 700 degrees, 800 degrees, something around that. This is going to be much over that, so I don't want zinc vapors depositing themselves over the inside of my kiln. Oops. Oh. So the whole point of this is just to minimize the amount of oxygen that the metal gets exposed to. There's probably better ways to do it, but this is the approach I'm taking right now. Another one is to submerge the parts in boric acid, and then the boric acid will melt and form a coating over it while you're heat treating it. And I might do that in the future sometime. So now we're ready to go, so let's just set them in the kiln and start the heat treating. Alright, so here are the parts in the kiln. I still have my control part left out. So I'm going to close the lid. So I do it while holding this. So close the lid, and then I'm going to come over and start the ramp up. And currently it's 59 Fahrenheit here in my workshop. And so we're going to start the heat treat up to 1550 degrees. I've got it set to take about an hour to get to 1550 degrees, and then I will take the parts out and submerge them in oil. Well, one of them I'll submerge in oil, the other one I'm going to leave, well actually both of them I'm going to submerge in oil to cool, to shock them down to about 100 degrees. One of them I will temper after, the other one I will not. So one will be full hardness, the other one will be around 39 Rockwell C, and we'll go from there. So now the kiln's heating up. We're currently at 196 Fahrenheit, heading to 1550 over the course of an hour, 200. And that, like I said, that'll take about an hour, and then it'll soak for 15 minutes. And then start cooling down to the 800 degrees that I want to temper at. That'll take a little while. So while that's cooling down, then I'll immerse it in the oil to lock in the grain structure and clean it off, and then get ready to temper one of the pieces. Alright, so here's what I'm going to do. In 7 minutes, it's been soaking for 23 minutes so far. It'll be a total of 30 when it's done at 1550 degrees Fahrenheit. I will open the lid, and I will, after putting on my gloves and protective gear, I will use this hook to grab the two parts out of the oven, and then I will walk them over to my can of heat treat oil and get them down to room temperature, more or less around 100 Fahrenheit, just warm to the touch. One of them will remain in there. The other one I will clean off the oil, and then it will go back in the heat treat oven over here, which will be cooling down to approximately 800 Fahrenheit, where it will temper the remaining part, which will set its hardness somewhat lower than the heat treated part, which will be max hardness. Alright, so a few minutes and we'll be ready to go. Alright, so here's the parts in the oven. As you can see, they are glowing red hot. So now just agitate the parts until they get down to room temperature, or around 100. And just keep I only have a gallon of oil, so I'm going to use a fan to keep the oil cool. You can see all the heat rising in the oil. Yeah, so they're still hot enough to exceed the smoke point of the oil. To hold the oil, I got a empty paint can, a brand new paint can from Lowe's. It was only $5, and when I'm done I can just leave the oil sealed in it, which will be convenient. These are pretty big chunks of steel. They're 1-inch diameter, so a lot of thermal mass. So it's taken quite a while to cool off. So in case you're wondering what I used, I bought this quenching oil from McMaster-Carr. This is their slow speed quenching oil. They have some higher speed quenching oil. So this is what I used. I've heard that you can use peanut oil. It's got a high smoke point and smells better than burning car engine oil, which is sort of what this smells like. Okay, so one part has gone. I have taken it out of the stainless steel protective covering, put it back in the oven. The other part is going to stay full hardness, so I'm just going to take it out of its stainless steel covering, clean off the excess oil that's on it, and then we'll move on to machining once the other one's done heat treating at 800 for about an hour. It's an hour per inch roughly for this material, for circular material. The goal is, you need to take into account the thermal conductivity of the material and make sure that you get the core of the material at the desired temperature. Alright, so here are the three pieces of metal we're going to work on. This is an untreated 4140 chromoly annealed piece as delivered from the vendor, roughly Rockwell C hardness of 13. This is a hardened and tempered piece, tempered to about 39, Rockwell C. And this one is the hardened, the heat treated only, and it could be between 54 and 59 Rockwell C hardness. Right off the bat, besides the obvious mill scale kind of stuff, I noticed that the normal chromoly, the annealed version, has a different ring to it than the hardened ones. So next step is to head over to the lathe and do some cutting. So the first piece we're going to cut is annealed chromoly steel, no heat treatment, should be Rockwell hardness 13. And this is the stuff, if you'll remember watching my other videos, that I had a really hard time getting any decent finish on it at all. So we're going to face it and we're going to run some longitudinal and see what the finish looks like. So we'll start with facing. So the in-feed I've got set, the RPMs are 1120 and the in-feed's a little over, well, it's exactly 2,000ths a revolution, which is very small. And if you remember right, maybe you don't, that I found that high speed made a better finish, but I can show you both. So let me touch off. And we'll take a light pass of 10,000ths. I found that larger passes don't work any better, seem to work a whole lot better. No, that's not quite touching. Here's a 20,000ths pass. Before I started this, I checked the height of my tool, and it's on. So, let me pull this out. See if you can take a look. The finish is not great, and that is the optimal combination that I was able to find before. Didn't matter whether it was a large or small bite, but high RPMs and low feed rate seem to be the best finish, and this is not great. Let's try one more pass. We'll take a bigger bite just to compare. So there's 30,000ths pass. The chips are breaking well, and they're blue, so it should be a good situation. Alright, so if I had to guess, in the annealed state, the grain structure, the grains are really large, so they tend to tear out a little more and make an uglier finish. If you notice, it's a pretty ugly finish. I mean, it's a lot better than it would be if I went slow, so I'll do another pass and go slowly for you so you can see the difference. Okay, so we're down to 440 RPM, so about 1/3 what we were before. And I'll do the same 30,000ths pass.
Sorry about the focus there. It's focusing on the more contrasty surface below it. Maybe I have to turn the light off. Alright, so that was slower. And that's even worse. You can see that. Alright, let's try some longitudinal cuts. Alright, so now we're going to do some longitudinal cuts, and we're going to start at the low speed first, with still a really low feed rate. So let me touch off. And first cut will be 25 thousandths. So you can hear, it sounds like it's scooping material. It sounds terrible. It does not sound like it's going to be a clean cut, and you can see that it's not. Just let me come out. So with your fingernail, you can hear it. See if I can get it for you. Terrible finish. So let's try higher RPM, same low feed rate, and of course higher feed rate only makes the situation worse, of course. That would be to be expected. Okay, so now we're going to a high RPM, back to the 1120 RPMs. Same 25 thousandths depth of cut. And you can hear and see it's better already. You can hardly feel the grooves now with your fingernail, but it's still not great by any stretch. Alright, so let's move on to the next sample. Okay, next we have the hardened and tempered material, so let's try and face that at slow speed first. We'll do a 25 thousandth depth of cut. So, not great. Let's go higher RPM. See if that improves things. So about 25 thousandths, blue chips now. This is a good sign. sounded like it was cutting better. We were getting turnings rather than chips. Yeah, the finish is definitely better. Here, let me pull that out for you. So the hardened and tempered at high speed definitely cut better than the annealed version. Okay, let's do some longitudinal cuts. Yeah, see, there's the annealed version next to it at high RPM. And see, it's really lousy. All right, let's do some longitudinal cuts. Okay, so we're going to continue with some longitudinal cuts on the tempered, the heat treated and tempered stock, and we'll start at low speed and do a 25 thousandths depth of cut. So at low speed, the finish is still a hell of a lot better than the just plain annealed. You can see that it kind of chunks have been torn out of the annealed one, whereas this is relatively smooth. I can feel a little bit with my fingernails. So let's try high speed. So we're continuing with the tempered stock. We're going back to high speed at 1120 RPMs. About 25 thousandths depth of cut again. Blue turnings coming off of it. Chip raker's not engaging. Finish already looks superb by comparison. And it is. There's a little bit of surface tarring, but you can't feel it with your fingernail anymore. Still shiny, and again here is compared to the plain annealed. So there's a much better finish, a little bit of really fine-grained sandpaper, and you're good to go. All right, let's move on to the heat-treated but not tempered, the hardest stock of them all, the stuff that is probably around between Rockwell 54 and 59 hardness. All right, so finally we are on the heat treated but not tempered. So this will be the hardest material of them all. Like I said earlier on several occasions, Rockwell 54 to 59, Rockwell C 54 to 59. So we're going to start with a facing cut, and we're going to start at slow speed. And I was squaring this up, and I don't think I can do 25 thousandths depth of cut very easily. So I'm going to zero that, and I'm going to do 10 thousandths, which I know isn't fair, but this material's a lot harder. So still, even in its hardest state, this material does not like low RPMs. I mean, the finish is definitely better than just the plain annealed state, but it's definitely not great, especially on the outer side. So let's jump to higher speed. So So we're going to do the same 10,000 depth of cut. And unfortunately, we got the surface scratched by material wedged between the tool and the work. See if we can do it again and improve that a little. So you can see that in the hardest state with its smallest grain size, I'm guessing smallest grain size, that we get the best finish. From my point of view, it's almost mirror finish. Let's see if I can show you. So I cannot feel any imperfections. It's glass. It's like a piece of glass. Obviously, there are some. Oops, you can't see that. So it's like a glass finish. I can't feel anything. It's perfectly smooth. My fingernail, absolutely nothing. There are some tiny imperfections, obviously, since you can see the blemishes, but they're too small to be felt. Let's try some longitudinal cuts. All right, so here we are back at slow speed, ready for a longitudinal cut. I'm going to take 10,000ths, and I know I've been taking smaller depth of cut. That doesn't help on the other two, by the way. I've tried it. I need to on this harder material. Although longitudinally, maybe it'll work. Let's try 25,000, see how that works out. So here we are at low speed, relatively speaking, 440 RPM. So it's a heck of a lot better finish than the annealed, but not great by any stretch. All right. Yeah, actually, it's pretty rough. All right, so let's go to the highest speed we've been using and go back for another 20,000, 25,000. You can see immediately the improvement in chips and the improvement in finish. It looks like we're cutting aluminum. That is I cannot feel anything with my fingernail. All right, so let's look at all three together. So here we are at the end, and from left to right we have softest to hardest. We have the annealed in the left, we have the heat treated and tempered in the middle, and the heat treated without tempering on the right. Rockwell hardness 13 on the left, 39 in the middle, 54 to 59 on the side and on the far right side. And I can't get better than that because I don't have any way to measure Rockwell hardness directly. That's just what the heat treating manual said it would be. And you can see the finishes. It definitely goes from worst to best. The harder it gets, the better it is. I'm guessing it's because the grain size gets smaller and it cuts taking out smaller bits, but it's significant improvement. See if you can see this. And let me show you the ends. So here's the same three pieces from left to right, softest to hardest. I put a little pencil mark on each one. Rockwell hardness 13, 39 and 54 to 59, and you will notice that the finish gets better as it gets harder. So that would be a lesson learned. Possibly heat treated and tempered would be an ideal middle solution if you were going to work the material and wanted to get a good finish out of it. Also notice how rough it is. So if I rub my finger over that pencil mark, it stays. The middle one, it comes off, and the one on the end doesn't stay at all. It comes right off instantly. So you can tell that this finish is much rougher, and you can feel it with the pencil too. This one has a little bit of roughness, and this one's like putting on a piece of glass. So there it is. I suppose if you need maximal hardness and are willing to put up with a fragile, potentially fragile part, then you could just heat treat it and not temper it. In any case, I hope this was helpful and hope to see you next time.